Hello, and welcome to my talk, in which I will present you nested named entity recognition and where sense disambiguation, which are core tasks for natural language understanding. I am Mustafa Jarrer from Birzeit University in Palestine, and actually this is me. In our group, we are known in building linguistic resources for natural language processing, which I will present today. This is the campus of our university, which is located in a town near Ramallah called Birzeit. Before starting, please give me 2-3 minutes to show you some of the linguistic resources we developed. Then you can understand where I came from to solve named entity recognition and where's this disambiguation. So we developed the lexicographic database, which contains about 150 lexicons, and we have them in one database. We also have the we developed the Arabic word net, or it's called the Arabic ontology, a formal Arabic word net. I will show it to you. We have also developed several annotated corpora for Arabic dialects with morphological annotations, NER, intents, head speech, and so on. So we have different corpora. We also have, or you can access even, our data and services through a set of APIs that we developed for different services. This is the link. It's also maybe worth to note that in our group, we received several awards, such as the Mohammed bin Rashid's Award for Arabic Language, Schumann's Award, and we have also been covered by several media stations. The lexicographic database, as I told you, contains about 150 lexicons, covers multiple types of dictionaries and dictionaries, thesaurus, glossaries, and so on, cover with multiple domains. So it's not all pure linguistic, but also we have domain-specific lexicons. We have been digitizing these dictionaries over about 10 or 11 years. So we have them from paper, typing, into Excel, into database, cleaning, and linking entries together, and so on. You can try it online through this link. It's large in terms of the number of concepts, lexical entries, sensets, translation pairs, glosses, semantic relations, and so on. The Arabic ontology, just to show it to you quickly. So you can be used as an Arabic wordnet if you are familiar with Arabic wordnet, and the tree in the ontology can be accessed through this link. The ontology is actually linked with the Princeton wordnet, with Wikidata, with also foundational ontologies like PFO and Dochi, and with other lexicons even. It's not, by the way, it's not large set, because this covers the core concepts mainly. The top levels of the ontology tree are just the small screenshot from the top levels. So we have an entity that can be an object or an occurrent or dependent entity or abstract or information entity. The object can be physical object or social object, and so on. So this is a tree that goes down to many levels. So I showed you the lexicographic database, the Arabic ontology. Quickly, I'll also show you our work on building morphologically annotated corpora for dialects, for Arabic dialects. We focus mainly on 11 dialects. Let me skip this. So in this link, you can access it. You can try it even online. You can also, by the way, you can type in English and retrieve a word in the dialect. So it's not the modern standard Arabic, it's the dialect. You can even see it, and it's all annotated, morphologically annotated. So this is just a quick demo about our work. Now, let me start to show you our recent work on named entities. So we built a large corpus with nested named entities called Wujud. As you know, what is NER, named entity recognition? So usually we build a corpus, annotate this corpus, and build some systems to recognize the entities. So this is an example. So we say Sammy works at Jimmy Carter Center. So Sammy here is a person. So we tag it with P pairs. So the P start means beginning. So beginning of the mention of the name. So works at is, we call it outside. So these are not entities. Jimmy Carter Center is the name of an organization. And so this is the B org. So the beginning of the entity until, so there is no end. So you say beginning, and then we say inside. It goes like this. We call this flat entities, and it's actually mature for most languages. So in most languages, you find corpora and systems to recognize entities. Okay. Recently, the research community started to look at something else. So we are now addressing what's called nested named entities. So this is the example. We say Jimmy Carter Center is actually not only an organization, but it's also a person. So P person, I person. This is called nested NER, and this is called flat NER. Now, for Arabic, to solve the issue of nested, so with the help of my colleagues, Muhammad Khaliliya and Sana Ghanem, we built a corpus, a large corpus, that contains about 550 tokens. That's actually the first nested, the first corpus for Arabic of nested entities. So please remember the name, it's called Wujud. It's also the richest in terms of the number of entities inside the corpus. We covered about 21 types of entities, I will show it to you, the entity types. And also we covered the modern standard Arabic and dialects. As you know, in Arabic, we have three Arabics actually. We have classical Arabic, the old one, and we have modern standard Arabic, and we have the dialects. So every country has its own dialects. So we cover MSc and dialect, and we cover multiple domains. We trained the model, a paired model, using this corpus, and we achieved this accuracy. I will show it to you. The types of entities we covered are, as I told you, 21. So person, like people's name; norm, what's called group of people, like you say, for example, Americans, Palestinians, Asians, Muslims, Christians, and so on. Groups of people. Occupations or professional titles, organizations, geopolitical entities, and locations. And there's a difference between geopolitical entity, we call it GBE, so it's the names of countries, cities, and so on. But locations are names of rivers, seas, and so on. So, for example, Europe, North America, Mediterranean Sea, and so on. We also have facilities or landmarks, names of places, like roads, buildings, and so on. We also cover events, date, time, language, website, laws, products, cardinal and ordinal. So we distinguish between cardinal numbers and ordinal numbers. Percent, quantity, unit, money, and currency. These are the types of entities we have them in the corpus, and that our model actually recognized them. We extracted our corpus from different sources that cover multiple domains like health, finance, ICT, law, elections, politics, migration, terrorism. In addition to history and culture, we also have some general topics that are discussed in social media, but these are the dialect ones. So in total, we have 550,000 tokens. We actually trained or fine-tuned BERT using the corpus, and we achieved these F1 scores, these accuracies with for each the entities. For example, for person, we achieved 91%, for NORB about 70, for occupations about 82, and so on. So the weighted average is 88.4%. Our model, by the way, just to mention that we didn't actually tackle a problem, even it's a small problem, very small problem and rare, but we didn't do it, which is entities, listed entities of the same type. Like, for example, we say the Workers' Association at Birzeit University. So it's the Workers' Association at Birzeit University is one entity, but Birzeit is another entity that it's inside the mention of the first one. So we call it nested of the same type. This is a little complicated when it comes to training, so we skip it because it's also small number. This is a demo and the links where you can download everything. You can try it. So if you click on this link, you see a form, you type a sentence, and then we show you the extracted entities. You can download the code from Arabic NER the GitHub, and also you can also, by the way, download even the model, fine-tuned model from Hugging Face. Now, this is our work on named entities. Now, let me switch to another task, and very interesting task, about where says disambiguation, which is known to be a very complex one. Okay. I did this work with my colleague, his name is Mustafa Jarrer, and this is our paper if you want to read more. Now, what is where says disambiguation, or WSD? Well, maybe many people knows it because in artificial intelligence, we have been working on this for many years, and we didn't achieve good results until recently. So given a context, or given a word in a context, so this is a sentence, and this word عيون, which means eyes, well, I should not point here because it doesn't mean I. So even in English, it has several meanings. So several meanings. So in Arabic, there are about maybe 14 meanings for the word I. Okay. What is, or which meaning is the correct one given this context, this sentence? This is called word sense disambiguation. Now, we actually solve this, and we get good results. But let me show you how we solve it. We built a corpus again, so we solved it using BERT. Okay, but how we represent the data set? We build a data set to address this problem. Our data set is pairs of gloss, which is the meaning definition or the sense, and the context. So this is the context, and this is the gloss. Each one of them is a gloss. So here the context and here the gloss, we pair, and we say this is true. we use the same context, but with different and wrong gloss. We call it false. We annotated, labeled it with false, and so on. We built 167,000 bears. We gave them to Bert on a task it's known to be called binary sequence pair classification task. And we get this accuracy, 84%. By the way, this is a high number, very high number. As far as I know, even in English, which is a highly resourced language, people are still also at the very beginning of 80s. Okay. We tried different BERTs, and the best one is called ARA-BERT version 2. And we are actually happy about this. So I will not go into details with this work, but this is the main idea. To give you a sense about the data set we have. So we have 100, as I said, 167,000 bears. 100 of them are false, and 60 are only 60 are true. It's not balanced, but it's okay. These bears are for 26,000 llamas, or dictionary entries, you can call them. So in average, we have 1.25% for each lemma, the number of concepts, the number of senses. You can download the data from this through this link, and you can also try it through another link here. You can scan the QR, and so you put the sentence and click WSD, and it will show you the gloss or the meaning of every word on this sentence. So if you change, if you keep this word and use it to mean another thing, it will show you another one. Well, it's not high, ideal, it's just 84% accuracy. Okay, last but not least, you can visit another link. Here we call it Lex API. It's a large set of web services to download data, to access web services, and so on, for lemmatization, dialects, the Arabic ontology, to search dictionaries, and so on, different things. And that's all. Thank you very much for listening, and I'm happy to take questions if you have. Thank you very much.